Hi students, good evening. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss your Module 3 homework. This will be the part 1 of the video. Please, before you view this video, it is highly recommended that you view the videos in the video playlist on GCD. GCD means Greatest Common Divisor, Modular Arithmetic and Algorithms. It is highly recommended that you view those videos first to get a good understanding of the concept before you view this video. Okay, let's get started. Question 1 is algorithms. Question 1 says, the following function written in pseudocode inputs income as a variable and outputs the tax corresponding to that income. You can think of this as a greatly simplified income tax. So the pseudocode, you put in the income and then you get what tax corresponds to that income. So the input is the income, the output is the tax corresponding to that income. And this is the pseudocode here. 1, if, the first line, if income is greater than or equal to 95,000, then conditional statement A, then set the tax, this means set the tax to be 14,500 plus 0.3 times income minus 95,000. Okay? Second, then the next line here, number 3 line, else, if it doesn't fit in that condition, then what do you do? Excuse me. If income is greater than or equal to 45,000, then set the tax, that's I here, set the tax to be 4,500 plus 0.2 times income minus 45,000. Okay? Then B here, else I here, the last line, set the tax to be 0.10 times the income. Okay, so let us explain this for a moment. This is a pseudocode. A pseudocode is just it's a high-level structured language. Okay, English is English. Like as you can see, this is English, but it's high-level structured English language. Why we say structured is because it's not. We have to put it in a, in a structure that will make meaning to all programming languages. When we write pseudocode, it's just generally. It doesn't correspond to a specific programming language. However, it has a structure, at least, that you could look at it and understand what they are talking about. So we say a pseudocode is a high-level structured English language used to describe algorithms. Okay? So this is used to describe algorithm. And what does it do? Just when you put in the income of the person, it tells you the tax for that person. Okay, just like our tax code, we have if you earn, so if you are within this income, then this should be your tax. If you're making below this, then you don't pay tax, or you pay a labor tax. So this is similar to that concept. If you make an income 95,000 or greater, then this will be your tax. If you make an income 45,000 or greater, but then you make income 45,000 or greater, but actually less than this, okay? Less than 95,000, but it's greater than or equal to 45,000. Then this will be your tax. Otherwise, if you make less than this income, if you make less than 45,000, then this will be your tax here. That is what this pseudocode is all about. It's just a structured language used to describe algorithms. That is what a pseudocode is. And it's not specific to any programming language. When you get into several programming languages, there are ways we code conditional statements. These are conditional statements. Okay? So the question here is, what is the pseudocode output? Of course, the output are the taxes. What is the pseudocode output for the following inputs? Explain your solution. So I've already explained this. The question, we have A, you have 27,500. B, you have 98,500. And C, you have 65,500. Okay, let's find their tax. So, tax for income of 27,500. What will be the tax? So the tax is going to be, this guy falls under here, 27,500 falls, falls here. Okay, as you can see, 27,500 it's not greater than 45,000. Okay, so it falls here. So this will be 0.10. You do 0.10 times 27,500. Okay, and that will give you a 10 times this is 27,500. 10. Then you do 0.1. So this will actually be because this is like 0.1 times this. So you do this and then 1 decimal place. So this is $2,750. This will be the tax for it. Okay? Yeah, 0.10 is 0.1. It's still 0.1. So when you do 1 times 27,500, it gives you 27,500. Now you have 1 decimal place, and you have that. So this is $2,750 will be the tax. Okay, and you can use your calculator to do it. Alright, now let's do the next one. 98,500. 98,500. So 98,500, we have that the tax will be, we look at this here, the 98,500 will fall in this category here because it is greater than 95,000. Okay, it's greater than 95,000. So this will be, we use that function there. So this will be 14,500. We use the condition, we use that condition. 14,500 plus 0.3 times the income is 98,500 minus 95,000. Okay? And this will give us 14,500 plus 0.3 times this is 0053 3,500. Okay? So this is 14,500 plus I will just use the calculator so I can be fast on this. And I can do it without calculator then. Let's use the calculator so we can be fast. So we're gonna multiply 3,500 times 0.3, and that gives us 1050. Okay, plus 14,500, and that is $15,550. Okay, $15,550. If you want to put the decimal 0.00, that's fine. It doesn't matter. You can put 0.00. Okay. So this will be the tax for someone that has an income of 98,500. Okay, let's do the next one, the C part. Uh, 65,500. So 65,500 is greater than 45,000. Okay, but it's less than this. Okay, so when you're writing this actually in a programming language and you put in the income, you know, it goes through here, income is not. And if it's not, then follow this condition. If the income is greater than or equal to 95,000, go ahead and execute this code. Execute the code. If not, follow this. You have another condition here. Okay. And then we see that the income is greater than 45,000. So this is the code that we are going to use for this. So the tax will be, set the tax to be 4,500 plus 0.2 times the income. In this case, this is 65,500. So 65,500 minus 45,000. Okay? And this will give us 4,500 plus 0.2 times, you have a 0, 5 minus 5, 0, 20,500. Okay? 20,500. Now, you can now go ahead and do this. This is 4,500 plus, let's go ahead and finish this. This is 4,100. Okay? And your answer will now be $8,600. $8,600. Okay? And that's it. That is it for question 1. Question 2 says, suppose that the array X consists of real numbers. So we have array X, question 2, array X consists of real numbers. You have X index 1, X index 2, up to the last element of the array, X index n. Okay? It says write a pseudocode program. Write a pseudocode program to compute the maximum of these numbers. Write a pseudocode program to compute the maximum of these numbers. So if we look at this question, with an array starts with index 0. Like the first element in an array is index 0. Okay, so the second element in an array is index 1. Third element is index 2. Fourth element is index 3. And that is it goes on like that. That is the way an array works. So you see that with this question, they said we should start from the index 1, which is the second element in the array. So the way we are going to write this pseudocode is this. We want to write a pseudocode to find the maximum of the numbers in this array. So what we are going to do is, first of all, we can set this element, the first index, which is the second element. Okay, we set the second element, the first index, which they told us to begin from. We set that to be the maximum first. We set it to be the maximum. Then we now say, okay, let us look through. Let's loop through the array. Okay, so we go to the element in the first index, which is the second element. Set it to be the maximum. Okay, then go to the element in the second index, which is the third element. Is the second element, is it greater than the third element? If it is greater than that, so you see there's a condition. So we have a loop and then we have a condition. So loop through the array, go to the next element. If this element is greater than that element, then leave that one to be the max. If it is not, set that next element to be the max. And keep on going until you loop through the whole array. When you loop through the whole array, it will keep setting the one to the max until you find the maximum number. Okay, let me repeat. So you set the first index, which is the second element, set it to be the max. Okay, set it to be the maximum. Then you have to loop. We introduce a for loop. Okay, loop through this array. Go to the next element, which is in the second index. Go to it. If the element in the first index is greater than the element in the second index, no problem. Let it continue. Allow that element to be the max. But if it is not, then if the element in the second index, which is the third element, is greater than the element in the first index, which is the second element, then set that element in the third index to be the max, and then move on to the next element and compare. Okay, so we have a loop and a condition. Okay, so the first thing we do is we set the max to be the element in the first index, which is the second element. Then we have to introduce a for loop. Okay, for, let's say I equal to 2. Okay, through the last element, which is the element in the n index. Okay, for this, from I equal to 2, look through the last index. Okay, element in the last index. Then we have a condition here. As we look, if we put a parenthesis, if xi, okay, if that element in the I, okay, if the element in this I index is greater than the max, if it is greater than max, okay, then set that max to be, set the max to be that element in the I index. Okay? Okay? And after that, set it, and then just when you're done, you return max. You return. When you're done, you return max. And that's it. That's the pseudocode. Okay? You see that this line, you see, because when you program, when you write computer programs, well, we have several editors that you could use that will line it up very well. Okay? But you see how the line is here. Okay? And that is your pseudocode. Question 3. It says, consider the following algorithm. Assume n to be a positive integer. Okay? Assume n to be a positive integer. Assume n to be a positive integer. So it says, we have the number, one line there. Set 0 to be x. Okay. Number 2, y to be, set 1 to be y. 3, while. So this is a while loop. This is a while loop. The one we did in 2, the one we did in question 2 is a for loop. But this one is a while loop. So while x is less than n, let me put my x like this. While x is less than n, okay, x, what do you set to be this? This is x plus 1. B, let me now change this one. Y, set y plus 3x. Let me put it 3x. Okay? 3x. And then number 4, line, your y, set, let me put y over 2n. Y over 2n. Okay? Just to modify the question, so I will not get in trouble. So, now let's go ahead and solve this. Let's go ahead and solve this. And they said, calculate what value of y the algorithm will compute for the following values of n. Okay, explain your solution. So the first one is a, n equal to 3, and then b, n equal to 5. So let's go ahead and solve this. Okay, let's look at the first loop or first iteration. First loop, or you can say first iteration. It doesn't matter. Okay, let's go ahead. Number one, I'm going to write this like this. X is 0. 2, y is 1. Actually, the first loop will be after this. We write this first. Number 1, x is 0. Okay? That's number 1. Number 2, y is 1. Okay? Then we look at the first, what happens in the first loop. First loop. Okay? While x is less than n. So x 0, n is 3. X is 0. So 0 is less than 3. So this will execute. Okay? The loop will execute. Will execute. It will execute. Okay? So what happens now? What will happen? This is, we now have 3a, x is x plus 1, and x will be 0 plus 1, so x is 1. Okay? And then b, y is y plus 3x. So y will be, y is 1 plus 3 times 1. Okay? 1 plus 3 times 1. So y will be 1 plus 3, which is 4. Y will be 4. Okay? And then the fourth command, we now have that our y will now be y over 2n. So our y will be 4 over 2 times n is 3. Okay? Which will give us 4 over 6. And that will give us 2 over 3. 2 over 3. Okay? That is the first loop. That's the first loop. Alright? We start afresh because this is, they want us to find the value of y. Okay, calculate what value of y the algorithm will compute for the following values of n. Okay, so n equal to 3. So we have not, we've not finished this. The program will keep running. So the next one, number 1 here, is our x will no longer be 0. Our x is 1. Okay, and number 2, our y is 4. Our y is 4. Okay, we won't use 2 over 3. We will not use 2 over 3. This is just the final output for n. Okay, we're going to use 4 rather than 2 over 3. Okay, yeah, because we keep doing it. Number 4 is like the last thing. The last thing. This will loop, and once it gets to here, it's not going straight to number 4. It's not. The program still continues. So once it gets to 3b, it continues. It continues back right away. Okay? Once it gets to 3b, we're not going to use 4. We will not, because the program has not finished. The program has not finished. So, y is now 4 in this case. Then we look at the second loop. The second loop, our n is still 3. Our x in this case is 1. 1 is less than 3. So it will execute. Okay? And when it does that, we have that our x is x plus 1. So our x will be 1 plus 1, which is 2. Our x is 2. And then our y is our y is y plus 3x. Okay, this number 4 is the last thing we are going to do when the program doesn't loop anymore, when it stops. But when it goes to 3, it continues. It continues. Then when it now stops, when it stops, then we now go to 4. That is the that is when it stops looping, then we now go straight to 4. So actually, we don't really need this. We do not need this. We really don't need this now. Okay? This is not necessary now. Not necessary. So let me go ahead and erase it anyway. Let me erase it so you don't get confused. Okay, let me erase it so you don't get confused. Because this is still looping. Yeah. So y will be y plus 3x. So y will be, our y is 4 plus 3 times 2. So y will be 4 plus 6. Okay, y will be 10. Y will be 10. That is the second loop. Then x is still here. X is less than 2. Here, I'm sorry, x is equal to 2. So, and 2 is less than 3. 2 is less than 3. Okay, so let's see what happens in the next part. So I'm going to erase this here. This is second loop. So in this case now, our x is equal to 2, and then our y is 10. Okay, our y is 10. Then number 3 here, while x is less than n, so our n is 3. Okay, our x is 2, so 2 is less than 3. 2 is less than 3, so we'll execute. This will execute. It will execute. Okay? And then the next one is the a part. The x is x plus 1. So x will be 2 plus 1. X will be 3. X will be 3. And then b part, y is y plus 3x. So y will be this y right here, 10 plus 3 times 3. 3 times 3. So y will be 10 plus 9. So y will be 19. Okay? And then we continue again. We continue again. This one is the third loop. Third loop. Write this third loop. Okay? We continue again here. Our x is equal to 3 and our y is 19. So number 3 statement, okay, command statement, our n is 3, our x is 3. So 3 is not less than 3. 3 is not less than 3. Okay, so loop breaks. Breaks. So it will not execute. Will not execute. Will not execute. It will not execute. So we now check our y. Our y is y over 2n. Whatever our y is, all over 2n. That's the number 4. Okay, it will keep looping until when it doesn't execute it anymore, you now go to number 4. And then this will be y is 19 over 2 times n, 2 times 3. So y will be 19 over 6. And that's the answer. Okay? That becomes the answer. This is for the A part. This is for the A part. So for this A part, when n is equal to 3, y will be 19 over 6. Now let's get the b part, n equal to 5. Okay? Let's get the b part, n equal to 5. So, we now continue from here, so we don't erase it. Let us continue from here. And then I'm going to just erase here. We're not doing the b part. Okay, we're doing the b part. B part is x n equal to 5. So we have that our x is 3 and then this is 19. Okay, so number 3 here, our n is 5, our x is 3. Okay, so 3 is less than 5, so it will execute. Loop will execute. Okay, will execute. Okay, loop will execute. And let's call this the fourth loop. Fourth loop. Fourth loop. The fourth loop. Okay, now we now look at A of it. X is x plus 1. So from here, x is our x is 3 plus 1, so x is 4. Okay, and then our b, y is y plus 3x. So y is 19 plus 3 times 4. Okay, plus 3 times 4. So y is 19 plus 12, and then y will be 31. Y is 31. Okay, and we go to the next one. We go to the next one. We start again from the first one, from the first command. X in this case is x is equal to 4. Okay, and then y will be the new y is 31. Okay, that's number 2. And number 3, while x is less than n, x is 4, n is 5, so 4 is less than 5. Okay, this will execute. It will execute. The code will execute, and this will be the fifth loop. Fifth loop. Okay, so A, x will be x plus 1. So our x will be 4 plus 1, and our x is 5, right? Then B, our y would be y plus 3x, and y will be, y is 31 plus 3 times 5. So y is 31 plus 15, and that will give us 46. 46. That will give us 46. Okay. Then we now do this one again. While loop. So our new x in this case will be 5, and our y is 46. Okay. Then number 3. While x is less than n, our x is 5, our n is 5. So 5 is not less than 5. 5 is not less than 5. Okay, so will not execute. This will not execute. It will break. It will break. So once it breaks, you now jump to number 4. And number 4, because 5 is not less than 5. Okay, 5 is equal to 5. So you add on to number 4. Number 4 will be y equal to y over 2n. So y will be 46 over 2 times 5. So y will be 46 over 10, which will be 23 over 5. So y is 23 over 5. So y is 23 over 5. Okay, please. These are the first, I think, these are the first three questions. That we've done. So, in the next video, we shall continue from question 4. Okay? Thank you so much for listening. If you have any questions, please feel free to ask me. If you are my student, please contact me through the school email. If you are not my student, if you have questions, you can contact me through my website. Okay? Thank you so much for listening, and you have a good evening.